Okay. So I think the more accurate title for this would be what I call the 3 ways of R, or how do you become a better code Googler, or Google R. What do I mean by that? Well, the R language, there's multiple approaches to it, and it can be used in many different ways, like a lot of other languages, right? I'm sure a lot of you are familiar with the different types of procedural programming, basically doing things in a top to bottom, step-by-step version, basically writing a script. That's pretty much how everybody starts their coding career, certainly when they're using a language like R or a language like JavaScript. Object-oriented programming, if you're familiar with, if you've done any work in Java, you know, C++, C#, Python, obviously. This is where you encapsulate things in objects. This isn't usually what we're doing in R. You can, and people do when they're building packages, but usually when you're building your analyses, it's not worth the effort for what you get out of it when you're using R. What R is mostly, I would say, is a way to do good functional programming. Or what I also say is what most people get to after they get done doing everything procedurally, and they want to do things a lot more efficiently. And this just means that you can pass data from a function to function, right? You can move, everything can be an input to something else. And I'll give you an example of that in a little bit. So in a lot of ways, it's like JavaScript that can also be used for all the different types of programming that are out there, right? That's a blessing and a curse. So for example, in JavaScript, you have what are called frameworks, right? And there's like, I think I just read something saying, you know, here's the top 20 frameworks you might want to learn in JavaScript. Some more popular ones are frameworks like React, Vue, Ember, Meteor. And there, like I said, there are many more. But there's a problem. People end up learning specifically to the framework alone, right? They learn how to be a React programmer. They learn how to be a Vue programmer. And it's very limiting, especially when you're trying to Google and use other people's code. So in R, I wouldn't exactly call them frameworks, but there's definitely different coding approaches that have emerged over the years. There's base, what I call, everybody calls it, it's, you know, base programming, championed by the purists who like to do it the old-fashioned way. Reminds me of the good old days when it used to be called S and not R. And honestly, if you know what you're doing, you know what's going on under the hood, you can write very fast code that does what you want it to do. Unfortunately, because the language evolved over a very long period of time, there weren't a lot of standards in how functions were written. So using one function to the next is very rarely consistent. So if you don't know what you're doing, it's real easy to get lost and confused. In response to that, you have efforts like tidy. I think you heard Baiwan talking about the tidyverse. If you've heard about Tibbles or dplyr, Stringer, many more libraries written in a tidy way. This is a framework championed by what I call the followers of Wickham, or the Wickham way. I'm not going to say it's a cult, but it's a cult. Just kidding, Baiwan. What it is an opinionated way to do functional programming. And by opinionated, I don't mean something negative. I mean, it just says, look, if you are going to do it this way, it will make things easier. And they're right. If you get everything into a tidy data format where every entity is a row with variables across columns, then you can use the tidyverse libraries, packages, and process everything in a very straightforward way. But it does make it rather verbose, and it's not necessarily any faster than base, and sometimes significantly slower. But it is a way that a lot of people get into using R. Then there's the data table way. As I like to say, championed by grumpy programmers who value speed and succinct syntax most. I would have to include myself as one of those. Really, we're just talking about a single package that provides a very, very fast data structure, where everything is modified in memory and you're not copying things back and forth. But it also comes along with its own syntax and its own read and write functions, which are super fast. So you end up being able to do things faster in a lot of ways. Having said that, a hybrid approach is certainly valid, where you combine the speed of data table with the programming style of tidy. And there are more and more packages out there that actually make that an easier thing to do. Why that didn't happen in the past, from everything that I can figure out, has everything to do with personalities of who developed one package versus who developed another. Obviously, they should be working together because it's open source and anybody can contribute. The community is actually starting to put packages together that basically let you use data table on the back end of tidy. And I can show you some easy ways to do that as well today. But the point I want to make is that if you're going to be a great R code Googler, which you definitely want to be, you need to be able to at least read and understand what's going on in the different code samples that are put in front of you, regardless of the approach. Right? If I see the little pipe marker, I can't go, oh, I don't know how that works, and move on. If I see something in data table syntax, again, you don't want to say, I don't want to use this. Somebody's already done the work for you. Right? So for today's objectives, I'm just going to give you a very cursory introduction to simple versions of each one of those approaches and doing a couple standard procedures that we always end up doing in our projects. Today, like most of the sessions that I will end up teaching, I don't want to keep you too long. I want to give you a good conceptual overview of what we're talking about. And then if you'd like to follow along, that's fine. You don't have to, but if you'd like to follow along with some of the files that are in the training repo, that's terrific. They're there. But then after getting a conceptual overview and playing with it a little bit, that's when I would like you to go off and do your data camp assignments, where you're going to get into a lot more depth and chance to practice. If you would like to follow along today in the training repo, these are the files that I will be going over. Give me just a second. There it is. I couldn't find the chat. Team Tidyverse, okay. Yeah, I'm sorry, guys. Just setting this up. Oh boy, how does everybody else do this? Where do you put these things? Let's put it over there. Okay, so let's get started. Let's shrink this up. Okay, I'm going to start out with the file, 3 ways to read a CSV, and actually add a 4th in there. Okay. First, I'm going to start off and show something that you might not know how to do that I found so useful once I figured out how to do it, and that's how to create yourself a simple data set for when you're doing testing. Right. Here you can see that here I'm just creating a data frame. 1, 2, 3, 4 with 5 columns, right? This is the way you manually create a data set. If I want to do a control return, build it, control return again, there you go. I built a data set, right? But if I want to build a big data set for testing things, it would take forever to do it this way. So instead, you want to do something like this. Oh, need a larger font. There we go. Is that a little better?
_3 with CSV 就跟我们的不一样的。
Okay, can everybody mute their microphone unless they're asking a question, please? Okay, here's where I start using some of the built-in functions in base R. Things like sequence, big letters, little letters, month abbreviation, and the handy dandy sample function, doing a sample. All right. So here I'm simply saying, okay, well, for that first column, give me sequence from 1 to 16 and go by twos. Here I'm saying, give me big letters, the first 8. Here I'm saying, give me small letters, the first 8. And same with months. All right. But that only gives me 8. So here I'm saying sample, I want 10,000 samples from the numbers between 10 and 20 with replacement. If I run that, there we go. Let me put my environment over here. There we go. If you look over here, I have 10,000 of 5 variables. Very handy, right? And in R, it's okay that these others did not have 10,000. They simply repeat. As you can see here, A, B, C, D, E, F, G, H, A, B starts repeating. So for what we're doing today, I'm going to create 3. And I'm going to save them into some files to use. So I'm going to call this one my small sample. The next one, I'm going to do the same thing, except I'm going to make it 1,000,000 rows. That's going to be my medium. And if we look over here in my files, you'll see them showing up here now. My small is 12.8 megs. Did I make that large? Here's my medium. 12, no, that's 12.8. Small is 130K. Yeah. Large, which has 10 million, is 127 megabytes. And I've created 3 of these because I want to show you that there's some differences depending on sizes as we go a little bit farther down. Okay, so starting out, here's another tip. There are packages for helping you time your code, but when you're doing something really simple, system time works just fine. Okay. So here I'm going to be doing base. What comes with R, read.csv. Right? I want to read it in. Anytime you're reading it in, you want to use strings as factors equals false. Otherwise, you end up having to translate the factors back and forth again. It's the old way of doing things. So if I want to run this, let's see what happens. All right. As you can see, this took 7.3 seconds to load up that CSV, right? And this is the 127 megabyte. Not terrible, but as you get into ones that are a gigabyte, that really, really adds up exponentially. Oh, thank you, Baiwan. Yes, strings as factors in the new 4.0, which I believe I'm running here, now defaults to false. Thank you, R. Okay. So what about Reader? From the Reader package, which is part of the tidyverse package we were talking about, they have something very similar. Instead of .csv, it's _csv. In fact, almost all of the tidyverse functions that are the same as the base, simply substitute an underscore. Let me run that one. Look at that. So instead of 7.3 seconds, I now have 3.1 seconds. So it's more efficient, and it does something like give me some handy information about what it just read in. So you have some double columns, and I have 3 character columns, right? Now you might be wondering what progress is. Well, when you're in a markdown document like this, visual cues can be given back to you, such as the progress of what's being read. So if I make that true, well, but be warned, they do make things a little nicer to understand what's going on, but sometimes they can have a big effect. So if you look down here now, I've got this bar going across the bottom telling me how far it's done, and over here, some percentages, 15, 16. You may have noticed everything has slowed down precipitously. Right? In fact, I'm not going to let it finish because I know it takes a couple minutes now to do something that took 7 seconds or 3 seconds before. So while little functions like that are handy when you're debugging, they can have a tremendous, you want to get rid of them. There we go, back to 3 seconds. Back to happy land. All right, well, what about data table? Data table has a function called fread. Fread is one of the fastest ways to read in, and fwrite is one of the fastest ways to write out. And I will show you what I mean. There you go, 0.6 seconds. All right, that's so 0.6 versus 3 versus 7. And believe you me, when you start working with really large files, the difference in those is tremendous. You want to do it as fast as you possibly can. So reading in with fread is great. Another thing I like about fread is you don't need to read everything in. Okay. Let's see. Do you have to pick one or the other? To read it in the data and then use the base to do? Yeah, you absolutely don't. You can use whatever you want, right? It's all about maximizing efficiency. How fast can I get it in? If I want to work in I don't want to work in a data table, I want to work in a data frame, I can say set data frame, and now it's a data frame. Right. Here what you see is that you don't need, unlike the others, you can just read in part of the file, right? It can be very inefficient on a large file to have to read everything in and then separate out what you want when you already knew in advance what you don't want. So here, I'm simply saying, drop columns 1 through 3. Right. There. So I've only got 4 and 5. Why? I've only got those last 2 columns. Well, what if I just want columns 1 through 3? Well, I can select. There you go. ABX and no YZ. And you can also do it by column name. Drop column name A and X, or select column name A and X. Very efficient. All right, now having said this, and this is one of the benefits of open source software, and I was complaining a little bit before about personalities not getting together and making their data tables work with their tidyverses. But because of that too, some competition has been set up, and now out of the tidyverse, at least associated with the tidyverse, comes a new one called Vroom, which is even faster than a data table for large sets usually. Or not. Okay, I'm not sure what it was doing processing there, but you see now it's 0.2. What was the other one? 0.6. Not a huge difference, but when it gets larger again, it can make a difference. You probably don't have Vroom installed on yours, so you'd have to do the install packages room if you want to experiment with that. And you probably don't have micro benchmark on there either. Micro benchmark is really good for debugging your code, figuring out where things are working fast and not, with a lot more specificity than simply doing system time all over the place. The reason I have it here is that I want to show you that it makes a difference, the size of the data that you're reading in as to which package you should be using. So what I've set up here, so sample file, I'm going to start with the small sample, right? So that's the 130K one. I'm going to read it in with base. I'm going to read it in with pay. I'm going to read it in with data table. And I'm going to read it in with Vroom. Okay. That actually doesn't need to be there. But by the way, if you're not familiar, you can load a library this way, library Vroom, or you can simply call the library name followed by 2 colons and then call the same function. And that's what's happening here. So what this is going to do is it's going to do each one of these, and it's going to do each one of them 10 times, right? And then I'm going to use ggplot to give me a visual readout of what just happened. So let's go. All right, that was nice and fast. So you can see for small files, you really can't beat fread. And Vroom is actually taking the longest. Now this would be because for Vroom to do what it does fast, it takes a little bit of setup. There's a little overhead at the beginning. So it's really not worth using it when you're talking about small files. Although to be realistic, here we're talking about the difference between single digit and double digit milliseconds. Everything pretty darn fast. But let me bring this up to, let's use the medium one instead. And what is that? That's at about almost 13 megabytes, all right? Do that. Uh-oh. Oh, medium small. Hold on. I have a medium small. Okay, there we go. Nice. It's taking a little bit longer because it's running these over and over again. Aha. Now you can see as we get larger, Vroom starts to make its argument that it can be just as good, if not better, than fread. And you see that the older ways of doing it, of reading things in, are getting slower and slower. I would run the same thing with large, but it would take us probably 10 minutes sitting here waiting for it to run. I think you all get the idea. Okay, any questions on reading CSVs in different ways and understanding the difference?
Yeah, so what's the practical application of these times? Because obviously with these data sets, we're only saving like tenths of seconds.
Yes.
What's the practical application of that? I mean, I feel like I can probably spare a tenth of a second here and there every now and again.
Absolutely, and that's when you should be, if these are the size files you're dealing with, you should be doing the type of coding that you're most comfortable with reading and writing, right? Where this really comes in is as soon as you start getting into gigabyte and larger files. Because the times go up and separate exponentially from each other. In fact, I would encourage you to take this file, go up top, and create yourself a really, really large sample file. and then walk back down through and run and see how long some of these things take. All of a sudden, something like a read.csv on like a 20 gig file, you're going to go away for dinner and come back and it might be done, right? Whereas with fread, it might be more like 3 or 4 minutes. So, does that answer your question?
Yeah, it did. Thank you.
Mm-hmm. Oh, nice. There's a practical example from Andrew saying Vroom has saved him 5 to 10 minutes working with 100+ gigabyte files. Fantastic. And I'm assuming that's saved you 5 to 10 minutes over fread. Yes, okay. All right. Well, let me move on to another example of 3 different ways to do things. So we read it in, we've got it, we've got this data set. How do we subset it? I'm gonna load our dplyr and data table here. Okay, here I'm gonna make just a very simple sample data set to work with. Columns, name, column 1, column 2, column 3, 1s, A, B, C, D, E, F. That's it. All right, so this is really about syntax differences. What if I just want to subset rows? Okay. Well, in base R, this is the syntax. So I'd start with the name. Here it's df, right? If I just run that, Control Enter, I see the whole thing. But I want to just get out where this one, where column 1 equals 2. Right. In base R, you always have to include the name of the data frame and the $, then the column name to filter on, to filter your rows on. This is one of the reasons I got in the habit way back when of naming things with like 2 or 3 letters, because you had to keep, if I had, this is my data frame, then this would have to be, this is my data frame, $ column 1. It gets really long and ridiculous. So that's a requirement when you're working in base. Also, you can't forget your comma. Right? You always have to have your comma there or it won't work. But there we go.
Hey, Aaron, this is Chris.
Yeah.
You just ran your load libraries to bring in dplyr and stuff. When I'm doing that, I'm getting the error message that we don't have that turned on by default as a package. Would that be possible? Are we missing a step?
Which package?
I was just, it was the dplyr package. So your line, yeah. The chunk,
you don't have dplyr installed.
Yeah, I had to install tidyverse.
Oh gosh.
So that took a little bit, but
Yeah, I apologize. Yeah, it's install packages. But you'll need to install the tidyverse, and that's going to take, it might take 15 minutes to do something like that. I apologize. I should have sent out that people needed to do that beforehand if they wanted to follow along.
Yeah, I was just thinking that's where it was at. I was like, why is it not running? And then I went through and looked and said, oh, it's not even there. So
can you all make sure that you're using the version 4 of R? The containers should have tidyverse and that's what I thought installed already.
I thought it was already in there.
So make sure that you're using the version 4. If you have selected 3.6, for example, then you might not have it.
Yeah, I'm looking.
I'll look into it.
Okay. Yeah, Joanna's saying the same thing happened to her for 4. But yeah, we will look into that because that's that's one of the set of packages that should be there by default.
I think that'll just help some people if they're trying to figure out why they couldn't make theirs run. That's the reason.
Thank you, Chris. Thank you.
Yep.
So for those, you can do the install packages on the tidyverse. But unfortunately, for the moment, you just have to follow along. Conceptual understanding is better anyways. Okay, so I have my, where was I? Subsetting rows using base, right? Okay, well, dplyr The tidyverse comes up with its own syntax for doing things. It does filtering and selecting. It likes to use verbs versus the traditional syntax. So here, what it does, so you use the function filter, you hand to it your data frame, and you tell it, well, I want column 1 to equal 2. And there we go. That same thing. All right, well, what about data table? Excuse me. On data table, the first thing you need is for your data frame to be turned into a data table. And that really is as simple as running the function setDT. And if you have a data table you want to turn into a data frame, it would be setDF, right? They're both, you know, a data table is based on the same underlying data frame. So now you'll see a couple improvements over, for being succinct, over base here. One is that I don't have to repeat the name of the data frame, $, name of the column. I can just put the column name. And the other is that I don't have to remember my comma afterwards, although it will work fine either way. And there we go. Okay, moving on now. So that was subsetting rows. What about subsetting columns? Well, that's what comes after that comma that I was talking about, right? So now I'm to the right side of that comma. And in data frame, you use your trusty C and you put the names of the columns. There we go. You remember I said in dplyr they have their own verbs. Instead of filter now it's select. So select from that data frame, and again, that same vector of column names. Now, what about data table? It's a little bit different. And I can turn it into a data table with setDT. In data table, I can just start typing the column name and you'll get a drop down telling you, letting you choose from what they are. That should work here. See? It's going to be a whole lot faster when you're going across doing a select, figuring out which columns you want to select than constantly having to put everything in parentheses. It uses this notation here, this dot, which is a shortcut for list. So this dot parentheses. And we get the same thing. Now also, if you're working in data table, it can work exactly like data frame, where you can also just put in the names if you like. And get the same result. Well, as you might have guessed, next is how do we do both at the same time, subsetting rows and columns? Well, we put together everything that was up above, right? df $column equals what it is, and then only give me these columns. All right. But in dplyr, when you really start seeing the difference, this is where it begins, right? This is where you start doing the piping. Well, here, instead, I'm saying take my data frame, send it to the filter function, right? Filter on column 1 equals 2, then send that next to the select function. So step by step by step. So you can see it's a lot different in terms of syntax and the way you think about it. All right, then for data table, quite a bit like data frame, except I don't have to put data frame in front of it, I think. But I could do it exactly like data frame, and that would work. as well. Mhm. Okay, any questions up till there? Oh, are there any significant differences in how long each of these take to subset? Great question. Yes, and I believe you'll get into that in the data camp tutorial. Data table automatically indexes everything that you're going to search on, and generally will do things in selecting in the blink of an eye. It'll be very, very fast. Let's see. Should we also know how to subset without column row names? Yes, I should have included that in here. You can also use the column and row numbers. And again, you will get into that in the data camp tutorial. Did anybody try and install the tidyverse, and did it ever finish? Oh, all right. Cool, cool, cool. Faster than I thought. Good, good to know. All right, here's a simple one that honestly used to confuse the heck out of me, and I'd always forget how to do it, and I always have to go look it up. Simply renaming a column, right? Because in base R, I'm going to make a data frame here. All right, if I want to change, here's column 1. If I'm like, oh, column B, it's supposed to be column 2. If I want to change that in base, you need to use the function names. See if I just run that, it gives me the names of my columns, which actually gives me a vector there. And then from that vector, I'm finding the names that equal column B, and then I'm sending into that column 2. As far as syntax goes, this is about as, I don't know, not great as it gets in my mind. This is the one I would always have to look up. And there we go. We renamed it. Well, thankfully, both dplyr and data table have different ways to do that. In dplyr, lo and behold, has one called rename. Send it your data frame, column name, the new column name, and then what you want it to be. And there we go. But even in this one, I find it confusing that I have to, in quotes, put the new column name first, and then find the old column name and put that after. I find that a little bit screwy. But in data table, and you don't have to turn it into a data table to do it. It'll just work on any data structure. It has a set names function. It takes the data frame, say, what are you looking for? What are you going to change it to? That's it. Ta-da. All right. Here's somebody whistling back there. Okay, moving on. Pipes. I'm going to start off with somebody else's work, which I thought was excellent. Why Pipes by Steve Simon. Okay. Let's say I want a vector listing of all possible values in a data frame, but I want them in order according to their frequency. Okay, well, here he has a test data frame he's built. Well, I can always get unique on that column. Great, A, B, C, D. And that's in the wrong order. want to give them in frequency order, I could start with something like the table command, which gives me the frequencies. Right? Great. Well, then what do I do with it? Well, then I want to sort it by those frequencies. Okay, so now I have the table function, and now I have the sort function. And this is where you start to understand what a functional language is, where I'm taking the output of one function and putting it straight into another function. Right? Okay, let's sort it. Almost there. Sort command goes from low to high. You want it the other way around. Okay, well, I'm going to put in the reverse function. So now I've got table to sort to reverse. All right. And one last thing, what you really wanted was just the names. So now you're going to do that names function again. So table to sort to reverse to names. All right. Now you start getting the efficiency of thinking functionally about things. But you might imagine these could have optional arguments too, right? Every one of these functions. If I start adding those in, this thing's going to get really long and really complicated and hard to look at. And that's where the pipe comes in, where I can take a column, pipe it to one function, pipe it to the next, and it all just starts to get more readable. Having said that, I'm going to bring up my own lesson here. All right, so here is an example of, function to function to function to function, right? All nested. And a couple of these, the function at the end has a bunch of, actually the group by has some parameters are being set, and the filter has some parameters are being set, and it starts to get confusing. So what do you do about that? Well, a traditional way to do that, here, I'll run it over here. Moving these windows around is pain. This is a more traditional way of doing this. Step by step, setting variables and then passing those variables on to the next line. Right? So in this case, I just filtered on, I think that's the how many barrels the carb has. Okay, it's filtered by that. And I take that and I send it here. Next stage is group by. And then again, same thing, take the B, put it in to C, C out to D, and finally print D. So I think you get where I'm going with this. And this is what piping tries to work to make more efficient or easier to read and work with. And it does in that. Take your data frame, then pipe it, pipe it, pipe it, pipe it, and I don't have to be writing all of these variable names that I'm passing back and forth. Right? Now, one thing, yeah, that's a by-one question right there, Sam. Since I'm the data table guy. If you're familiar with SQL or anything else doing group by, this is hard to explain actually. It's different in dplyr because group by just sets up what it's going to do in the future. It doesn't actually do any grouping yet until you send it to summarize. Right? So make a note to do some, I'm going to send you guys some group bys. It's kind of hard to explain verbally.
It basically creates a different data type. And based on the data type, the summarize will understand, oh, this is a group by or a collection data frame that's indexed by some key. So I'm going to operate Basically, instead of just summarize the table, I'm gonna summarize each of those tables and then combine the result. It's basically providing information to the function that it should have a different behavior, basically.
Yeah. I mean, it's a summary function, right? If I wanted to count all of the men and women on some population poll in Virginia, right? I could say, give me a count grouped by gender. Great. It'll add them all up. Male equals this number. Female equals this number. I think that concept is easy to get, especially if you play with some demonstrations. The part in dplyr that I find a little mystifying is that what's nice is about piping is I can run that much code, or I can run that much code, right? Step by step, going all the way through to figure out what's going on step by step in my process. When you do it with group by, you don't get anything different. So it gets confusing. Just summarize is waiting for it. Okay, but I will come up with a couple examples to show that too. Let's see, dot is assumed first. What does that mean? In your dplyr functions, in your tidyverse functions, the assumption for every function is that the data that came out of the last one is going to be the first argument in, which is why you can just pipe it real easy like this, right? But does that mean you can't use all of the old functions that were there? No, not at all. You can definitely use them. So here, my linear model function, right, which you see the first thing on the left actually is the formula, not the data itself. It instead has a data parameter that you set. Well, when you're working with piping, that is defaulted to dot. So if you're ever working with a function that the first argument is not the data set, you use dot. And it knows what to do. There we go. All right. Well, what about data table? Here I'm going to create a sample data set, A and B. So in data table, you can quote unquote pipe as well. What I mean by that is, here's my data table, my DT. What I've highlighted here, this is the way in data table, by the way, the colon equals, that I can very quickly create a new column. As I'm saying, in that data table, give me a new column called X, which is the square root of B. All right? Let me run just that part. Let's show you. And there you go, with this new X column, right? Well, in data table, I can just keep following it up with additional square brackets, one after the other after the other. So what you see here is me creating X, and then I can create Y, and then I can create Z. And it's all being done on one line. Right? So that, when you're talking about things that aren't too long, it's terribly efficient. You can think that way. I'm just pass this to this to this to this, without, it's not nearly as verbose. Having said that, when it does start to get long and you want to break lines, right? This is the way you do it in data table. You actually have to start with the next bracket, then return, and start with the next bracket and then return. And that's why I call this multiple lines U. That's really ugly. I find very difficult to understand what I'm looking at, you know, although it certainly works. And this is where I get to what I brought up before. There's absolutely no reason that you can't do things in a hybrid fashion. And this is one that I do quite often, is I use the McGritter pipe, and I use the fact that dot stands for the data, the data coming in, and you can do it exactly the same way. So I do the first step, pipe to the next, right? Just make sure I put my dot, and pipe to the next. And there you go. And personally, I find this a lot more readable than this. So Baiwan posted something. Oh, is that, I believe, is Meditor? I believe that is through a series of functions. Yes, yes, Telly. Piping means passing object through a series of functions. Yep. Data object, exactly. Without having to set a bunch of intermediate variables that you're actually not going to use for anything other than passing it to the next one. And you can bet your bottom dollar when you're doing your Googling and you see a bunch of these, it's almost always tidyverse functions. Right? But so you can use them with any functions. Baiwan? What you posted, Meditor, is that the package for
Yes,
doing...
it provides the same syntax as tidyverse, but using data tables in the backend.
Okay, great. Thank you.
You don't have to compromise, then yeah, you can use whatever you like.
Right. So yeah, early, in one of my slides early on, I said that the community was creating packages that actually combined it, and Meditor, I guess, is the latest one that does that. So you don't even have to do the dot over there. Do it just like you write your tidyverse. It was great. Thank you, Marlon. Okay, that is all I have to give you a conceptual overview of what the different three ways of, what three different popular ways, I'm sure there's more, of doing your R coding is, and hopefully giving you a way that you can then, when you're Googling, take advantage of whatever data or whatever code you find, and not have to back off because it has funny symbols or is formatted a different way than you're used to doing it. And to bring that home, you have some homework over the weekend. Actually, I think I made it due next Tuesday. That's not enough time, let me know. In data camp, one is the data manipulation with dplyr, which is just gonna have you go through a bunch of exercises in dplyr, and then the same thing with data table. And I'll tell you, if you've got both of these things down, you are a power user. Power analyst? I don't know. You're doing all right for yourself, and you're going to be well set to then jump into the more advanced topics. Also knowing these two is going to give you a lot of power to do what you do 80% of the time, which is actually manipulate data. Okay, having said that, are there any final questions? I will bring up some of these files got changed at the last minute, and I will be updating the repo so that you can get them. Can I please repeat the homework assignments? Yes. And if you should have gotten notices from Data Camp that you had assignments, and they're for these two classes that are right here: data manipulation with dplyr, data manipulation with data table. No, there's not a file with that. When you log into data table, it will tell you what your assignments are.
Data camp.
I'm sorry, data camp.
Hey, Aaron, this is Chris.
Yeah.
We're working on putting together a list to send you just a few changes for email addresses.
Okay.
Or we found out a few of our students have used DataCamp extensively in the past, and it's better to use those accounts. So Kelsey and I work on that, and during our end of the week debrief, we'll get that compiled, and I'll send you an email. So
okay.
Everybody should have access soon.
Yeah, I thought that might be what was happening. Yep, I recall. Yeah, if they have another email address, that would work great. All right.
For the file IO, basically reading data and writing out data, just as some people in the chat have mentioned, for small data, it might not matter. For big data, that's a better approach to use efficiency or more efficient methods in R. Eventually, I believe in a couple of weeks from now, we'll go into databases, which is yet a different approach on how to basically have it faster in memory or make some of those transformations that might be limited by in memory in R. So that's something that we'll cover other alternatives further on. And there is also just saving the files or the objects in binary for R. So R data,
Right.
which is another way. So this is like one way and probably the one that most of you will be using. But if a task requires something different, then what we're trying to give you is a sense of how to choose the tool for the task at hand. The more tools you know, the more options you have, and the better you are prepared to tackle any task.
Exactly. Exactly. Yeah, and we'll find when we go over the databases in SQL in general for accessing databases. At that time, I can show you that what's going on behind the scenes in all of this is actually just SQL, but written in R syntax. Okay. Barring any more questions? Going once, going twice? I wish everybody a fantastic weekend. Have fun with data camp and get outside. Thank you, everybody.